prior to looking at the announcement, it's critical to initially comprehend the meaning of what is being examined. The Large Hadron Collider (LHC), operated by CERN, represents an extraordinary achievement in science. Spanning 17 miles, this massive network of superconducting magnets is not only the largest but also the most powerful particle accelerator in existence. It stands as a remarkable example of human creativity and intellectual advancement. Surprisingly, the LHC is so powerful that it can recreate conditions similar to those present at the birth of the universe. However, as we explore the vast nature of the cosmos, one must wonder, could this machine, which aims to unlock the mysteries of existence, inadvertently expose us to unforeseen risks? The role of CERN and the LHC. Founded in 1954, CERN is one of the world's most prestigious scientific research organizations, comprising 23 member countries and a vast community of researchers. It functions as a hub for collaboration and innovation. While the LHC is its flagship project, it is just one part of a vast network of particle accelerators and experiments. Think of the LHC as a racetrack, not for cars or horses, but for subatomic particles competing in a race of speed, precision, and the very fabric of spacetime. Inside the LHC, protons are accelerated to nearly the speed of light, mimicking the energy levels that existed at the moment of the Big Bang. The resulting collisions generate temperatures far higher than those found at the core of the Sun. A system of magnets guides the protons along their path, and advanced cooling systems keep the magnets at temperatures lower than those found in space. These collisions occur at 4 specific points within the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, collect data. Each detector has a unique function, providing different perspectives on the outcomes of these collisions. Together, they function as massive cameras, capturing images of the aftermath. Scientists analyze this data to uncover elusive particles, such as the Higgs boson, often referred to as the God particle, and other phenomena that could help decipher the building blocks of the universe. The pursuit of knowledge and the risks involved. By focusing on the subatomic world, scientists aim to gain a deeper understanding of the universe. However, every new discovery tends to raise even more questions. The LHC is not just an instrument, it represents humanity's relentless curiosity and quest for knowledge. It embodies our drive to understand the forces that govern existence. However, as we push the boundaries of the unknown, we must also confront the ethical and existential dilemmas that accompany this pursuit. What dangers could arise from probing too deeply into the unknown? Could our quest for knowledge inadvertently unleash forces beyond our control? A shocking revelation from CERN. At CERN, where the limits of human understanding are constantly tested, a disturbing realization has surfaced, one that has unsettled even the most experienced scientists. Brian Cox, a former CERN researcher and respected voice in particle physics, recently made a startling statement that has captured global attention and concern. According to Cox, the LHC's goal is to recreate a miniature version of the Big Bang, a small-scale simulation of the event that birthed our universe. He also explained the LHC's immense potential for groundbreaking discoveries, such as shedding light on the mystery of dark matter, an enigmatic substance that comprises a huge portion of the universe. The possibility of harnessing the fundamental forces of the universe is undoubtedly thrilling, but it also comes with inherent risks. Could the LHC create a black hole? The idea of a miniature Big Bang is not just theoretical. It is a phenomenon that actually occurs inside the LHC, where extreme heat, pressure, and energy are generated, mimicking the conditions at the very beginning of the universe. With such immense power comes great responsibility. What if something goes wrong? This concern is not new. In 1978, Russian physicist Anatoly Bugorsky experienced a life-altering accident while working with a U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia. A malfunction caused a proton beam to strike him. The beam, traveling at nearly unimaginable speeds, pierced his skull, entering from the back and exiting through his nose. Despite the flash of light he experienced, brighter than 1,000 suns, he remained conscious and even walked to seek medical attention. The aftermath of the incident was both fascinating and alarming. Bugorsky lost hearing in one ear and suffered partial facial paralysis. Yet, remarkably, his cognitive abilities remained intact, and he continued his scientific career. His experience serves as a stark reminder of the power and potential danger inherent in particle accelerators. The risks associated with a particle collider like the LHC cannot be underestimated. There are genuine concerns about unintended reactions that could alter the very fabric of reality. Some scientists fear that the LHC could create a miniature black hole. What would happen if the LHC created a black hole? Black holes are regions of space where gravity is so intense that nothing, not even light, can escape. They are destructive, mysterious forces, lurking at the edges of the universe. The idea that the LHC could create even a tiny black hole is both awe-inspiring and terrifying. Could such a black hole grow uncontrollably, consuming the Earth from the inside out? CERN scientists have reassured the public that any black hole formed would be extremely unstable and would dissipate instantly. Still, the mere possibility of such an event has sparked widespread debate and concern. The science behind it. To understand how the LHC could potentially generate a black hole, we must first examine how particle accelerators work. When protons collide at nearly light speeds, the energy released is so intense that it could bend the very fabric of spacetime. Imagine a trampoline stretched tight, then picture dropping a heavy object onto it. The fabric bends, and if the object is heavy enough, it could create a deep indentation, pulling everything nearby into it. This simplified analogy gives us a glimpse of what the LHC could do to spacetime on a quantum scale. At this quantum level, where the laws of physics often appear strange and unpredictable, a theory has emerged suggesting the existence of extra dimensions beyond our familiar 3 dimensions of space and 1 of time. If these extra dimensions do exist, the LHC could potentially access them, possibly forming a gravitational well that could create a tiny black hole. The warning from renowned physicists. The potential for such an event has drawn attention from leading physicists, including the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson could become unstable at extremely high energies, potentially leading to catastrophic events such as vacuum decay. Similarly, renowned astrophysicist Sir Martin Rees has voiced concerns about the LHC's experiments. In his book on humanity's future, he explored the potential dangers posed by particle accelerators, particularly the remote possibility of vacuum instability. While he acknowledged the low probability of such an event occurring, he emphasized that even a small chance warrants serious consideration. Conclusion: the stakes are high, and the margin for error is razor-thin. CERN researchers have conducted extensive simulations and safety analyses, taking extreme precautions to ensure their experiments are safe. Even Brian Cox acknowledges the concerns surrounding the LHC but insists that strict safety measures are in place, including thorough reviews and protocols to ensure the collider operates securely. Most extreme watchfulness. As per Cox, the energies engaged with LHC tests are undeniably not exactly those that normally occur on the planet. The possibility of creating a stable black hole is cosmically low. Even if one were to form, it would be so small and unstable that it would quickly disappear, releasing a burst of energy, as predicted by Hawking's theory of radiation. Some have hypothesized that LHC experiments could open a portal to another universe or dimension. Although this idea is largely dismissed by mainstream scientists, it has sparked the imagination of many, fueling myths and rumors. What lies beyond our universe? Could we accidentally unleash forces or entities that we do not fully understand? The concept of parallel dimensions is not new. String theory, a leading candidate for a unified theory of everything, suggests the possibility of more than the 4 dimensions we experience, 3 of space and 1 of time. These extra dimensions may be hidden from our perception, but under extreme conditions, they could theoretically be accessed. Imagine the LHC as a key, unlocking pathways to realms that have remained concealed since the dawn of humanity. When protons collide at energies never before seen on Earth, they could create ripples that probe these hidden dimensions. While this idea remains speculative, it highlights the allure of the unknown. The possibility of discovering other dimensions continues to captivate the public, despite the fact that mainstream scientists remain skeptical about the LHC opening a gateway to another universe, or to hell itself. Still, the notion of the LHC as a massive key unlocking new realities endures, igniting the imagination of many. So, should we be concerned about the risks associated with the LHC? It's easy to get caught up in sensational headlines and fears of a cosmic catastrophe, but the reality is that scientists at CERN are highly aware of the potential risks. They have taken extensive precautions to ensure the safety of their experiments and continuously monitor and assess their work with extreme diligence. The potential rewards of their research, such as uncovering the mysteries of dark matter, discovering new particles, and enhancing our understanding of the universe, are truly remarkable. While these achievements represent a tremendous leap forward in human knowledge, they are not without risk. Like all great scientific advancements, the LHC's experiments raise important ethical questions. Could the creation of exotic particles or the exploration of high-energy conditions trigger consequences we cannot foresee? These questions require careful reflection on the broader implications of science as a whole. The Large Hadron Collider stands as a testament to human ingenuity and curiosity. It has already led to groundbreaking discoveries in particle physics, shedding light on the mysteries of the universe. However, as we venture into these unknown realms, we must remain cautious and aware of the risks involved. The pursuit of knowledge is one of humanity's most ambitious endeavors, yet it is not without its challenges. The LHC represents the cutting edge of scientific exploration, where theory meets experimentation, and where the very foundations of our understanding of the universe are being tested. The journey of discovery is rarely without risk, and the LHC is no exception. It pushes the boundaries of physics, striving to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. Yet, as we continue to explore these frontiers, we must also consider the ethical and existential questions that arise from manipulating the forces of the universe. The risks of unforeseen consequences, whether for our planet or the very fabric of space-time itself, remain a challenge that demands thoughtful consideration. Nevertheless, the pursuit of knowledge remains one of humanity's most noble endeavors. The LHC's experiments, while risky, offer us a glimpse into the vast, uncharted domains of science that await discovery. As we stand on the threshold of revelation, the journey to unlock the universe's secrets requires both ambition and caution. The LHC is not only a pinnacle of human technological achievement but also a powerful tool that could reshape our understanding of everything, from the smallest particles to the largest cosmic phenomena. Each breakthrough opens new questions, leading us down new paths of exploration. The journey of scientific discovery, though fraught with uncertainty, holds the promise of revelations that could redefine our understanding of the universe, our place in it, and the very laws that govern it. One of the most profound aspects of the LHC's experiments lies in the intersection between theory and reality. For decades, physicists have sought to unify the forces that shape the universe: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The hope has always been to reconcile these forces into a single framework, a theory that explains everything. The LHC has played a crucial role in providing experimental evidence and insights that bring us closer to this elusive goal. Its work not only enhances our understanding of particle physics but also holds the key to unveiling the fundamental truths of existence itself. The ethical dilemmas associated with such experiments are significant. The pursuit of knowledge has always been accompanied by risks. However, when those risks involve altering the very fabric of spacetime, the stakes become even higher. Could an experiment at the LHC inadvertently trigger a phenomenon we do not yet understand, leading to consequences that are impossible to predict? This question continues to be debated by scientists, philosophers, and ethicists alike. As we venture into these unknown realms, we must carefully consider the responsibility that comes with wielding such immense power. Despite the potential dangers, however, few would argue that the pursuit of scientific progress is not worth the risk. The rewards, new technologies, medical breakthroughs, and an expanded understanding of the universe, are immense. The discoveries made by the LHC so far have already revolutionized the scientific landscape. From identifying the Higgs boson to advancing our understanding of dark matter, these breakthroughs have far-reaching implications, not only for physics but for numerous other fields that rely on this fundamental knowledge. As we continue to push the boundaries of what is possible, the LHC serves as a reminder that science is never free from uncertainties. No experiment is entirely without risk, and the LHC, as grand and powerful as it may be, is no exception. Yet, with each risk comes the potential for monumental discoveries. The LHC is a symbol of humanity's relentless quest for knowledge. Driven by the desire to understand the universe, explore the depths of reality, and uncover the forces that govern everything from the tiniest particles to the largest galaxies. It may carry risks, but it also represents the pinnacle of human achievement in the realm of particle physics, a tool that allows us to explore the deepest questions of existence, challenge the very laws of nature, and seek answers to the mysteries that have eluded us for centuries. Whether the LHC will ultimately unlock new dimensions, open gateways to parallel universes, or trigger unforeseen phenomena remains uncertain. However, we do know that it is one of the most powerful tools ever created, capable of uncovering secrets about the universe that were once thought to be beyond our reach. The potential for discovery is boundless. As we continue to venture further into the unknown, we are reminded that science is a journey, one that requires both boldness and responsibility. As the experiments at CERN progress, we must remain mindful of the possibilities, risks, and extraordinary potential for new understanding that lies ahead. The LHC, while representing the forefront of modern science, is also a reflection of our deeper quest for meaning and comprehension in a vast and mysterious universe. Every new discovery brings us closer to a fuller understanding of the forces that shape our reality.